Hi and welcome everybody to the first exercise session for the Taxation Bachelor course. In today's exercise session, we will talk about the theoretical tools of public finance. So we will basically go through how to draw a budget constraint, what a relative price is, and we'll talk a little bit about utility maximization and actually solve one utility maximization problem. So in the first exercise, we are asked to derive relative prices. So relative prices are basically expressing the value of one good in terms of prices that consumers have to pay in terms of another good. So the first question is, assume that the price of a bus trip is $2 and the price for rideshare is $5.50. What is the relative price of a trip using a rideshare company in terms of bus trips? What happens when the price of a bus trip rises to 2.75? Okay, so um, we are basically asked to express um, ride shares in terms of bus trips. So a bus trip costs $2. So bus trip is $2, and rideshare is 5.50. Okay, so if you simply divide 5.50 by 2, what you will get is 2.75, which means that one rideshare is worth 2.75 bus trips. Okay, so for one rideshare, trip, you can get 2.75 bus trips. And even though 2.75 bus trips does not make so much sense, we simply assume that you can have half of a bus trip or something like this. Yeah, so don't worry so much about this. So for one rideshare, you can get 2.75. So the relative price of a rideshare is 2.75 bus trips. So this would be the answer. Now, what happens next is that the price of a bus ride is increasing to 2.75. So now bus trip is going to $2.75. Now the relative price is 5.50, since the price of a rideshare is still the same, divided by 2.75, and this is equal to 2. Therefore, for one rideshare trip, you can get 2 bus trips. Okay, so the relative price obviously decreased because the price of a bus trip increased. Okay, so before you could get 2.75 bus trips for one ride share that you would give up. Now it's 2 bus trips. So bus trips became relatively more expensive than ride shares. Okay, so this is the answer to the question. In exercise number 2, we are asked to draw a demand curve for a particular demand curve which is given here, and we are asked to calculate the price elasticity of demand when the price changes from $5 to $10 and from $10 to $15. And that's what we're supposed to do. So the demand curve is given by 250 minus 10p. Good. Just go to the next page. So be Q is given by 250 minus 10p. Okay. Oh, sorry, that's not B, that's exercise 2, sorry. Good. Yeah, so let's start with the coordinate system. This should be enough. So I will have steps of 50, then I will have 100, going all the way up to 250. So this is Q, the quantity, and this is on the x-axis. On the y-axis, we will have the prices, and the prices will start $5, go to $10, 15, 20, and 25. This is the price. So there are many ways to draw it. One simple way is to find the intercepts. So the kind of intersection between the line and the x and the y-axis. So in order to be able to derive this, we need to set the demand curve equal to 0. So find intercepts. That's what we will do. So first, we want the demand curve when the price is 0. Demand at p equals 0. So for this, we simply enter p equal to 0 into this demand curve that we have there. So this is 250, which tells us that when the price is equal to 0, then the demand curve, so the demand will be 250. Therefore, the demand curve will cross the x-axis here at 250. At the same time, what we want to know is when does the demand curve cross the y-axis. So for this, we need the so-called choke price, or the I think it's called saturation price. So the price where no demand is there anymore. So price at which demand is 0. So typically you can you can see it immediately. So if you enter p equal to 25, this is p equal 25. Let me write a q here just to you know that it's quantity here. So if the price is equal to 25, we have 250 minus 10 times 25. 10 times 25 is 250. Therefore, the demand is equal to 0. Hence, at a price of 25, the demand will be equal to 0. And then this will be the intersection between the demand curve and the y-axis. Now, the final step is simply to connect the 2 points that we calculated right now. So that's what we will be doing next. Okay, and this is the budget curve. Sorry, this is the not the budget curve. This is the demand function for the demand curve for the function which we had here above. Okay, good. So in the next step, we are asked to calculate different elasticities. So elasticities refer to relative changes in the demand when the price is changing. Okay, so elasticity oh, no S here, sorry. So elasticity is or elasticity, no, let me do it like different. To be just more precise, it is the price elasticity of demand. So price elasticity of demand. This is the relative change in demand when the price is changing. There is a quite simple formula for this. By E, I will simply denote the elasticity. So the elasticity is simply the quantity before the price change, which I will simply call Q old, minus the quantity under new prices. This we divide by the old quantity, and the whole term will be divided by the following fraction. So then you take the old price, subtract from this the new price, then you divide this by the old price, and this is basically the elasticity. So it tells you how the quantity relatively changes when the price relatively changes. Yeah, and this is what we will be using now. So let's start with the first case. The price increases. So let's do something like this here. So first, the price goes from $5 to $10. Okay, so the price goes from $5 to $10. Let us simply use the formula. So what happens with the quantity? So the quantity goes from 200. So it's 200 when the price is 5. So quantity is falling from 200 to 150. Then using the formula, so what do we have? Now we have all the information that we need. So the formula is then 200 minus 150 divided by 200. The whole thing will then be divided by 5 minus 10. So this is the new price divided by 5. And what we then have is minus 0.25. And this is the kind of price elasticity of demand when the price is increasing from $5 to $10. So in the second step, we have the situation where the price is going from $10 then to $15. In this situation, the quantity goes from 150 to 100. And if you enter those expressions, so just have an E here. If you enter those expressions into the formula, you will end up with E being equal to minus 0.66, so approximately 0.66. And in the third step, we consider a situation where the price is going from $15 to $20. And then if we plug in again, we have minus 1.51, yeah, approximately. So this is then the elasticity if the price increases from $15 to $20. Yeah, so basically the statement here, so if we consider, for instance, the first elasticity when the price is increasing from $5 to $10, it's basically saying that if the price is doubling, so doubling from $5, then the demand will decrease by 25%. Okay, that's what the statement basically is. And here, at the second step, we have when the price is increasing by from $10 to $15, then the demand will go down by 66%. So for each percentage point, it will go down by 66%. And those are the statements that we can make with respect to the elasticity. And one thing that you should observe is that the elasticity, even though the demand function is linear, is not equal. So it's not the same over different parts of the demand function, even though it's linear. So a linear function always has the same slope, but the elasticity must not be the same because obviously the quantity is changing depending on where you are in the demand curve. Yeah, so keep this in mind.